Question number 19. It reads, in gravity-free space, a small ball is placed at the center of a box of the same mass. The ball and the box both are moving with velocity v towards the wall. Assume all collisions to be perfectly elastic. Answer these two parts. One is how many possible collisions are going to be there in this figure. And finally, we need to find velocities of the box and the ball and the final position relative to the box of this ball after all possible collisions. So this is a wall which is a fixed. This is the box which is moving with velocity v. Along with there is a ball at the center which is also moving with the same velocity, and they are not in contact. So they will keep on moving with this relative position forever until and unless somebody obstructed. So here this wall is going to be the obstruction. So this going to move till this wall. When this box is going to in contact with this wall, then the first collision is going to be. So the first collision is going to be when the box comes in contact with the wall. And since this collision is elastic, then you'll find the box will get the velocity in reverse direction, and magnitude will remain the same. So its velocity will get reversed. That's the first figure. This is the first. This is the figure just after the first collision. Now you'll find during this first collision, this ball will not be affected. It will keep on moving. Assuming the time of collision was negligible, so this ball is still in the center of this box, and this box is now started moving towards this ball, or we can say towards this right side. Now the distance between this box and ball now is going to reduce. Earlier it was maintained, and then this distance is going to be reduced, and there will be time coming when these two are going to come in contact. So that will be we are going to call as a second collision. So here I have written, assuming the box length is L, the entire length is L, then you'll find this separation between these two is going to be this box edge and this ball. This separation is going to be L by 2, and they are approaching towards each other with v plus v, that is 2v velocity. Then t equal to L by 2 divided by twice v, that is L by 4v. This is going to be the time after which you will find the second collision is going to take place, and this is the time measured after first collision. So after first collision, you will find the second collision will be taking place L by 4v time after, and at that instant this box, this edge and this ball will be in contact. Now this figure, the figure which I'm calling as a second figure, this is just after the second collision. So what is going to be just after the second collision? Then you'll find again there is going to be elastic collision. We know this collision is elastic, and these two objects which are involved, like ball and the box, they are of identical mass. So whenever there is elastic collision between identical masses, then velocities are exchanged. As per this norms, you will find these velocities which were there before the collision will now get reversed or exchanged. So the box will now be moving towards leftwards with the velocity v, and this ball is going to move towards right with velocity v. So this is the second figure which describes the situation just after the second collision. Now how much this distance would be, we can measure it. This distance is going to be s is equal to vt, because this has been moving with v, this edge was moving with v, and it took this much L by 4v time. So this distance is going to be basically L by 4. So this was L by 4 distance, and this ball is also had traveled L by 4. So center of the box is here, which is L by 4 from this center is going to of course admit. So you will find this ball initial position and this ball second collision position has gap of L by 4, right? So just after second collision, you'll find ball is going to move in this direction, and this edge of the box is going to, entire box is going to move towards leftwards. So the separation is going to increase now, and the rate of separation is going to be twice v again. So here I've written just after the second collision, velocities will get exchanged, that we have explained or understood in the second figure. Then there is going to be third collision taking place, and that third collision is going to be between this wall and this box. and that will take again L by 4 V time, because L by 4 distance has to be covered with this velocity V by this box. So that will be the time. In this time, you'll find this ball is going to move forward. By what amount? V into T we can say. That means L by 4. So if it is moving L by 4 further and this box wall is coming L by 4, so this ball is going to reach at the center during the third collision. And just after the third collision, you'll find the box will get its velocity reverse because this wall is a fixed. So again, this box is going to have the velocity V, and that velocity is going to be rightwards, and the ball will be at the center moving towards right with the same velocity. Now the relative separation is not going to change, and then in this rightward direction there's no obstruction coming in. Then you'll find just after third collision this relative position will maintain as very similar as it was earlier before the first collision. And here one more important point is that towards right there is no wall, so no more further collision is going to take place, neither between ball and the box nor between the box and the wall. So this is the final situation which will keep on moving, right? So the question says how many collisions are possible. So we say this was the first collision, second collision, third collision. Only 3 collisions are possible. And then we need to answer the second part, which says find find velocities of box and ball and position of the ball related to the box after all possible collisions. So this is the figure that is describing the B part's responses. That means the velocity of box is V towards right, velocity of the ball is V towards right, and the relative position of the ball with respect to box is at the box center. So that's the B part answer. So that's how we are able to answer A part as well as B part. That means we answered the complete question, right? I hope you got it. Thank you.